So I've been hands-on involved in connecting a dozen solar farms so far. I've done the application grid design, cable route design for another 14, and I'm working on another dozen at the moment. The summary of what I'm going to go and say is the only realistic option for connecting these farms is a 33 kV network. We've got a limited number of connection opportunities, and they're getting fewer. I'll talk to you about that. The AOMB, the areas of outstanding natural beauty and the national parks exclude a lot of the opportunities we have to connect solar farms. I'll talk about why it's important to keep cable routes simple. And there's two parts of there's two fundamental parts of the process: the application to the offer side of things and the offer to the energization side of things. We want to build a solar farm. There's sort of fundamentally three sort of networks we could connect it to: 11, 33, and 132. And there's some 6,000 volt stuff out there. There's some 66,000, some 22,000 volts stuff out there. But it's fundamentally it's three networks. I'd like to connect my solar farms to the 11 kV network because it's everywhere. It's all these little poles that you see with three wires going across with the smaller insulators and the pole-mounted transformers. And that's across the country. And that's used to sort of push power to schools, factories, farms. So that's everywhere. So lots of opportunities. I'd love to do that. It's nice and cheap to connect to. The problem with it is often the capacity, generation capacity I can squeeze down the wires, I'm restricted to sort of 2 megawatts or so. It varies, it's a case-by-case thing, but the thermal capacity of the wire and the switches restricts me to about 2 megawatts. And also, if I do connect at the 11 kV network, to switch the thing off so I can connect my farm into it, I have to switch all the customers off on that line, all the farms and hospitals, and so it's got some challenges. The 33 kV network, there's not as much of it, and I'll show you that in a second. There's bagged more capacity, perhaps up to 25 meg, maybe more. I can squirt down the 33 kV wires. Much of the capacity is now gone. It costs a lot more, and it's very competitive. When I started doing this, I was making applications to connect on 33 kV parts of the network in Cornwall, and mine was the only application onto that part of the network. When we apply now, virtually every time it's competitive. Virtually every time. I'm up against other people wanting that capacity. 132, we could build big solar parks and connect them at the 132 network, but the challenges are the planning complexity is huge, the delivery time, the cost consequently is huge, but the delivery time scale is in years. And given the rocky political ride that we've had in solar, even if a bunch of developers wanted to get together and connect a bunch of solar parks onto a strengthened 132 part of the network, we could afford to do it, but none of us would have the confidence, I guess, to invest their funds at the start for a 4-year upgrade. So 33 is where it's at. So that's Western Power in the southwest, and as I said, the green lines are their 33 kV wires, and you'll see there's lots of white gaps. So the number of fields that we have that are close to or underneath the 33 kV wires is limited to start off with, because it's quite sparse, a 33 kV network. And we're also finding parts of it are full up. So we've got a big problem going on here, which if I'm right, I think that's a pi-worthy sub, the 132 sub. So any generation onto a 33 kV network all around here inevitably goes back through the pi-worthy sub. The 132 that leads to the pi-worthy sub is full, so we'd have to put any more generation in a whole part of Cornwall around here, we'd have to strengthen the 132, and I forget what the cable goes back to, but we're talking about building 70 kilometres of 132 cable to strengthen that part before any of us can develop any more solar parks around here.
What would it cost to doing
that? It was mentioned, I've forgotten. It's more the timescale, Paul. Yeah, even if you can afford it, I can't bank on 4 years that it's going to be economic to build solar parks in 4 years. Right now, we don't hunt for solar farms, new solar farms down there anymore. We hunt elsewhere. Similar-ish story in the SSE's region. So we've got the south, mid-south of the UK. Again, the green wires are the 33 kV wires. Yeah, the dark areas there, they're the AONB areas and the national park areas. So if you overlay those on top of the previous maps I showed you, that there's large parts of the 33 kV network that are gone to us now already, and that's when we're just about a gigawatt of large-scale solar. Interestingly, we did what that's the North Wessex Downs AONB. We did one right there, right in the middle. And we're doing another one in there, but it's terrifically difficult to get it through planning. Okay, so moving on. We want to build a solar farm. So this is a picture of a project we looked at a little while ago. So we want to build a solar farm over there. And I'm working with a chap who owns all the land that way, basically, for thousands of acres. We picked a nice spot. The substation is over here, the other side of Alresford. So we had to find a route through the town to get to it. Now, ideally, I want to pick solar farms that are underneath the wires because it's nice and easy to connect them. But when folks ring us and they say they've got lots of land and can we find a nice spot, we go over there and try to work it out, basically. But this one, the challenges that you face in getting from there to there, we had to, one route was to go through Alresford, and we've got telecoms, gas, electric services to cross all the way through, road closures to the middle of Alresford. When we got over here, we've got Rivers Environment Agency, we've got rivers to cross. They were talking about diverting this river to allow us to build a big pits either side of it, put the cable underneath, and then re-divert the river back over when we're done. So it became impossible to find a route to connect that solar farm. There's two aspects to the. I'll come on to that next, actually. Yeah, there's two aspects. There's the cable route and the access route that you need to get right when you're building these solar farms. And there are both physical difficulties and huge legal, commercial difficulties that you face. So the physical difficulties that we often face when we're trying to connect the solar farm to the network is there might be gas mains, high pressure gas mains, sort of diameter gas mains, and the process of going underneath the gas main is quite involved. You have to get National Grid out, do all sorts of tests, test digs. It's involved. We're doing a solar park over the top of a fuel line at the moment that supplies Lynham. Well, it did supply Lynham with aviation fuel. You get bridges and tunnels. Bridges are interesting. Bridges, you tend to find that the actual bridge structure itself may be owned by the Environment Agency or maybe owned by Network Rail, but the 300 mil of tarmac over the top is owned by the highways. And you have to get legal approval of both the highways and the bridge owner and the D&O. And the D&O doesn't like it because the D&O wants cables buried this deep, but you've only got this deep to play with. And it becomes awfully difficult. And there's a list of other sort of physical difficulties that we face over there. Legal difficulties, gosh, these are difficult. So Network Rail. I came into Paddington this morning, and I'm trying to put a cable underneath the main line into Paddington at the moment, and it's a twin line, so it's not quite as wide as this room. So I've got three things to get right with. There are three teams to get on the case with Network Rail. One is the Wayleaves team, so I've got the legal right to do it. Two is the asset protection team that want to protect the railway line. And three is the delivery team. The Wayleaves team, hands up, how much do you think that the Wayleaves team want to charge me just as a fee to put a cable from there to there? Any guesses? Sorry?
50,000.
Higher. 150? Higher. No, £200,000. That's where they start, to put a cable from there to there. That's just a fee. Well, that's what I say. And then they point to us this legal case where there's a theoretical justification that they deserve a portion of my profit on that development. Right. Yeah, that's the one. So I plead poverty, and we're negotiating, as you might imagine. The complication involved in putting the cable from there to there under the railway line is quite immense. It involves taking possession of the railway line 3 times. Once to install targets on there, overnight, surveying targets. We then have to go and survey the line continuously for a number of weeks to start off with, to just check if it's moving anyway. We have to agree how we're going to do the job. All the CVs of the people have to be approved. We go and do the job. I have to have a maintenance team on standby, a Network Rail maintenance team on standby, just in case that when I dig my directionally drill my hole this deep underneath the railway line, this diameter at 15 feet underneath it, if the railway line just moves a little bit, they'll close the whole thing, and the maintenance crew have to come out and start tamping down and trying to lift the railway line back up. And so it's really involved, and that whole process will cost me another 50,000 on top of the 200. So railway lines are very difficult things to cross. And you get similar stories with the National Grid, Oil Pipelines Agency. The National Grid, as an example at the moment, it's taken me since October the 25th until yesterday to get out of them a 3-page deed of consent document. But that's been harassing them since, 10 months or so it's taken me to get one document out of them so I can proceed on a project. Okay. With cable and access routes, keep it simple. One of the other things is unadopted land. We've had solar farms down the end of tracks that the ownership of the track is not clear, which is fine. It's not owned by that bloke, it's not owned by that bloke, it's just a track, it's an unadopted lane. The problem comes that the DNO won't energise my solar farm until I find out who does own the track, or somehow get a court order to take possession of it, so then they can put an easement on it. Not because of the cables going down there, because they want the permanent right to access their switchgear near the solar farm. And if I can't give them that legally, they won't energise my solar farm. So the process, the first bit of the process is the application to offer. Creating a compliant offer is relatively formulaic at the moment now. But when we first started doing it, it took us 3 months of working with Western Power. I think ours was the first compliant solar farm offer they accepted before they could start the clock of giving us an application. One of the things that people don't often do is apply for enough import capacity. So people fill their ENA 1 forms in and apply to the DNO. They want 60 kilowatts of import capacity so they can switch the solar farm and power the heaters and lights. But then when they build the solar farm, they installed 150 kilowatts of heaters and lights and computers and things, and find that the the DNO won't energise the whole solar farm because they've got the wrong input capacity. One of the things I think we do particularly well that I think other people don't seem to do very well is we talk to the primary design teams. I mean, I go along to Reading and have a coffee with and buy some donuts, and we sit down and we have a look at the maps. And all my applications, I talk to the primary design teams at SSE, UKPN, Western Power before I make the application. I talk to them and have coffees with them during the application, whilst it's being sort of designed. And sometimes I can sort of squeeze my capacity request down, or I can modify it. But if anyone's applying for grid connections, I do encourage you to talk to the primary design team. Go and meet them. Don't just wait for the response. It makes a big difference. And the next piece is when you accept the offer and then move to energising. It's horrendously complex, the whole process. It really is. But this often trips people up, given one of the challenges we have in solar is that we have to switch these farms on by the end of March each year. So our timescales are constrained. Oftentimes we're getting planning permission coming out delayed. So we might get planning permission coming out in September, in October, sometimes in November of the year, leaving sort of 4 months. But the switchgear takes 6 months before it arrives. So my last day for ordering switchgear is the end of August generally. And that might be 2 months before I've even got my planning permission on our solar farm. So there's a bit of a difficulty there. Another key challenge to the whole solar farm building piece at the moment is the booking and outage date. We're forced by the timing of the ROC shutdown to switch these things on by the end of March, but end of March is still within the winter outage period for the DNOs. So if you're unlucky, the DNO will say to you that they're not going to switch that line off in the clock change period. They'll switch it off 1st of April, but that's no good to you. But they won't switch it off beforehand. But it depends, it's line dependent. So you take a bit of a gamble on the outage if you're not careful. And the other key piece about the whole thing, the legals can be horrifically complex within the DNOs. If you're developing parks not just in the AOMBs but near AOMBs, as we are at the moment, we have to get Section 37 consent, which means forms to local council, forms back from the local council, forms to DEC, forms back from DEC, before the DNO will allow you to energise the park. But if any of you are newish to developing these solar farms, there are plenty of experienced teams out there to go and hire, and I do encourage you to hire them. Just a few examples of what we've managed to do, so of what is possible. In 2011, we in Western Power we switched on 5 33 connections within 5 months from accepting the offers, which was an interesting period. We were tunnelling underneath the high-pressure gas mains and also aviation fuel aviation fuel lines in SSE's region. We're doing routes that are 6.8 kilometres long. Again, the landowner came to us with some land rather than actually hunting for solar farms 7 kilometres away from the power line. And we're doing some interesting ones in Western Power's region too. When you go through towns, the number of services you're crossing is just mind-boggling, and it really does slow your whole grid connection piece down. So preference is to keep it simple. So conclusions, 33 kV is the only way to go. There are limited connection opportunities, and they're getting far fewer at an alarming rate actually. Keep the cable route simple. Speak to the DNOs during the application phase, and hire experts. when you're trying to energise these things. It is terrifically complex. And I've seen a number of overseas firms particularly find huge difficulty in energising their parks. And I know the end of this March, just gone, a number of the new to the UK overseas firms failed to switch on their projects before the end of March because lack of experience in UK ways of doing this. Okay, and that's it.